All right, my friends. Now we're going to move on with radicals. In 6-2, we're going to be talking about multiplying and dividing radical expressions. Okay? The good news is pretty darn easy. There is no bad news. It's pretty simple. If the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b will equal the nth root of ab. The only catch here, guys, is that the index must be equal. The index must be equal. Okay? In order to multiply in radical expressions, they must have the same index. That's the only caveat. Do you know what that means, caveat? It's a warning. It's a warning. Caveat. It's the only caveat, it's the only warning. So if I have the square root of 3 times the square root of 8, that's going to equal the square root of 24. And then guess what, guys? This is where the beauty of radicals come. Isn't 24 4 times 6? Yeah. What's the square root of 4? 2. So this would equal 2 times the square root of 6. These skills are going to be very awesome by the time we finish. And then I'm going to show you guys how to use the quadratic formula. And then when you get to the quadratic formula, you understand why we went through all these steps first. Because you're going to get a lot of crazy radical answers. And if you know how to reduce them, then you'll have no problems, okay? So this is what we're doing. You got to have the same root, guys. Got to have the same index. Yeah, index or root. You're absolutely right. Yes, whenever the question was, once I multiplied these and I had the square root of 24, do I have to reduce it? Yes. Just like a regular fraction from now on, guys, whenever we multiply or divide or we're adding radicals, we have to simplify that final answer, please, and thank you. All right. So example 1. Can you simplify the product of the radical expressions? Okay. So this is just saying can you, and then explain. So for our explanation, we will or we will not. Okay. So this is no. Why? They have a different index. You cannot do it. Period. Done. B. Yes, this would be the cube root of negative 8, which would equal negative 2. Negative 2, gentlemen. Can I multiply the 4th root of 7 and the 5th? But I got the same radicand. Oh, but I don't have the same root. Very good. No. I know, man. I got to get on that, man. I got to get on your level. Sorry about that, guys. How about this? 5th root of negative 5 times 5th root of negative 2. Now, in this case, can I simplify it at all? No. No. Whoever said yeah, no, guys. This is a 2 times 5. I need a set of 5 numbers to pull one out. This is just 2 times 5. There's nothing. I cannot do anything here. So that is it. My answer here is the 5th root of 10. Period. For those of you who said yes, take a look at why you made that mistake, please, so we can go ahead and fix it. All right, now, besides multiplying, we're going to do a little bit of heavier simplifying now. So what's the cube root of 54x to the 5th? Break it down, boys. How does 54 break down? Okay, I wouldn't have gone that route, but that's fine. 9 times 6? Okay. Okay. Whoever said that, I'm very proud of you. You got 3 3s. 1, 2, 3. So that pulls out as 1, 3. But I have what left over in the cube root? A 2, right? How many times is 5 going to 3? Okay, so I have 1x that comes out, and what I have left over? X squared. Does that make sense, guys? Really take a look at that. Because that's big on the SAT as well, on the ACT. And next year, how you guys are going to very advanced geometry. Your teacher is going to be extremely happy with you when you guys know how to do this. And you're going to be extremely happy with yourself because this skill is really, really used a lot in geometry. Sir, and trig. The question was, if it was the 5th root of, let's just say, 54 again, x cubed. In this case, guys, when I broke this down, you know that it's broke down to 3 3s and a 2. Do I have 5 3s that I can pull out? So that would stay. Does How many times does 3 go into 5? It doesn't, right? 5 doesn't go into 3 evenly. So if I told you to simplify, you're done. Because I don't have a set of 5 of anything here. Does that make sense, my brother? Sir, and then sir. Okay, thank you. What's 5 divided by 3? That equals 1, and you have 2/3 left over, right? So you have 1x that comes out, and I have 2 left over. Thank you, son. Questions are great, guys. Great questions today. Continue? Okay. Let's do cube root of 128 x to the 7th. I honestly, to be honest with you, I don't know what this one is. I don't know this off the top of my head. So let's break it down. I like 64 and 2. I like that one. Yeah. 4, 2, and then 2 and 2, and then 2 and 2. Okay, I know. There's a lot of numbers. Don't stress. Check it out. I got 1, 2, 3, so that comes out as a 2. Then I have 1, 2, 3, that comes out as another 2. But I have a 2 left over, so I know that has to stay there. We're going to work just with the numbers right now. Does everyone see why I pulled out 2 2s and I have 1 2 left over? Awesome. Now, how much? 7 divided by 3? X squared. And what's left over? X. Because 3 goes into 7, 2 equal times, but there's 1 left over. So my total answer here is 4x squared cube root of 2x. Yes, I like those. I like that word. Oh, it's easy, Mr. Mo. Good. Good. Does that make sense so far? It's kind of just building on the other one, right? May I continue? Thank you, gentlemen. All right. Now let's get to the real stuff. Can I multiply these first of all? Yeah, because they're the same root, okay? Now I'm going to give you a little bit of a hint. Some people like to go 720 and then break it down. I'm not one of those people. I'm a simple kind of guy. I like to make my life as easy as possible. So what I'm going to do here, gentlemen, is I'm going to go the square root of 72 times 10, and then I will combine the x and the y's because those are Mickey Mouse. X to the 4th, y to the 5th. Why did I keep it separated though, Mr. Morrow? Well, I'm going to break it down anyways, right? So if I go ahead and say 720, don't I have to break it down to 72 times 10 anyways? Yeah. So, you know, in my opinion, then I go 36 times 2, and then 5 times 2. Now look, we can keep breaking this down if you wanted to, guys. But you guys are smarter than that. You can hopefully identify perfect squares. What's the square root of 36? So I'm going to have a 6 come out. Bye-bye. Don't I have a 2 and a 2? So that comes out as a 2, correct? Right, because I have square root. Are you guys with me? That's by. So now I have left over in there a 5. Does everyone see how I took those numbers out and why I left the 5 in? Yeah. This is the time, guys. You know me. I don't care. Ask. Okay. Now, x to the 4th, we get an x squared. Y to the 5th, we get an x squared, and we have 1 y left over. So my answer is 12 x squared y squared square root of 5y. Don't get fancy and try to multiply these together is my suggestion. Set them up next to each other and break it down. Sir. Okay, the second question is, are you able to first break down 72x cubed y squared and then multiply it to this? Yes. I find that a little bit time consuming, in my opinion. I'd rather you do it all in one setup like this, bro. And this is what happens also. Let's say you get the first one right and you screw up on the second one. Now everything's wrong. And vice versa. Okay? Sir? How do you multiply with leftover? I don't understand what you mean. Like the 5y. Okay, that 5y, yeah. Okay, let's say I'm taking this answer now, and I multiply this times the square root of 4y cubed. This would be 12 x squared y squared times the square root of 20 y to the 4th. Because remember, as long as they have the same index, I can multiply the insides. And now in this case, I can take out 2 more y's, right? And I also have a 20 here now, right? So I can break this down into 4 times 5, correct? So I'm going to take out a 2, making this 24. X squared, take out 2 y's, making this y to the 4th. And then I'd have a square root of 5 left over. Does that make sense what we just did there, guys? From here to here to here to here? Does that make sense? Did I answer your question? Awesome. May I continue, gentlemen? All right. Now we're talking about division. Division I kind of already hooked you up with, guys. If the nth root of a and the nth root of b are real numbers, remember b cannot equal 0 because then it's in the denominator is 0, and you can't have a denominator in 0, it's undefined. Then basically the square root, the nth root of a divided by the nth root of b is in one big fashion the nth root of a over b, or vice versa. We already saw that in the last lesson. I can break down the division however I want to. Why is that important? Because sometimes I'll give you something like this, man. Square root of 3/16. A lot of people will give up on me. They'll go, oh, but look, Morrow, but 3/16, how did you get that? You forgot one key. This is the square root of 3 over the square root of 16. So this answer is the square root of 3 over 4. Okay? Don't let one number, don't let this 3 elude you. Don't let it mess you up. You got this. You're better than that. You with me, guys? All right. Let's check out some examples, please. Okay. In this case, this looks crazy. Don't make it crazy. This is going to be 18x to the 5th over 2x cubed. Before you start going crazy and, oh, what do I... Relax. Remember that the radical is kind of like, not kind of, it is a grouping symbol. So if you can simplify stuff within the radical first before taking any square roots out, do it. So this would really become 9x squared. Thank you. Thank you. Yeah, I hope you guys remember, when you divide exponents, you subtract them. Okay, you guys know this. So this answer would be 3x. Done. Made something complicated into something really easy. Does that make sense, gentlemen? Okay. Here, same thing. There's going to be the cube root of 162y to the 5th over 3y squared. So it's going to be 54, right? So this is going to be the cube root of 54y cubed. Now the cube root of 54, let's break it down. 2 and 27. Hey, wait a second. I know the cube root of 27 is, so I got 3y, because I have y cubed. 3 divided by 3 is 1. You have one set that comes out. And I have the cube root of 2 left over. Does that make sense, guys? It's actually pretty fun, isn't it? It's kind of like a puzzle. Yeah, you're not agreeing with me that it's fun. You're laughing at me now, but not. See, I get a little bit more excited with this math stuff than I guess than you guys. Okay, I think it's pretty fun. It's like a puzzle. Yes, sir. No, yeah. The question was, what's the cube root of whatever 7x to the 5th divided by the square root of 8x to the 3rd? You can't do it. You wouldn't be able to divide those. In order to multiply or divide, have to have the same index. Thank you, son. May I continue, gentlemen? Okay, hold on. Huh? Okay, I have the square root of 4. Ah, okay, that's something different, my brothers. That's a great question, son. Thank you. If you had the square root of 4 over the cube root of 8, okay, technically, you cannot put these together, but in this particular case, it's very rare that they would do this, but if they do, I don't want you to say, oh, you can't simplify this. Square root of 4 is 2, cube root of 8 is 2. This would be 1 in that case. That would work. Only because I was able to simplify both radicals into whole numbers. I got you. Thank you, son. Does that make sense, guys? Sir? Yeah. The question was, how would you write the answer to this one? No solution, or you can't simplify. Any other questions so far? All right. Now, the most important part of radicals, guys, is this right here. Sometimes, whenever you have a radical in the denominator, you must rationalize the denominator. It's called rationalizing because you cannot, by definition, have a radical in the denominator. You just can't. Mathematically speaking, you can't do it, period. So, great moral, what do? You do something called rationalize. I'm going to repeat that a couple times. Rationalize. Because you're going to see it on the SAT, you're going to see it on the ACT. And sometimes you're going to see a question on the test and it'll say, whatever, add or subtract or multiply or perform the indicated operation and rationalize all denominators. Rationalize means getting rid of the radical in the denominator. Now, how do we do that? Okay. We're going to think back to the whole, how do we get a perfect square or a perfect cube or a perfect fifth? In this particular case, gentlemen, hear me out. You have the square root of 2. I can't do anything with that, right? That doesn't simplify, right? How many 2's do I need, though, to pull 1, 2 out? You need 2 in total, right? So you have 1, so guess what? I'm going to multiply the top and bottom by what I need to pull this out. So this is now going to equal square root of 2 over 2. Why? Whenever you multiply the square root of a times the square root of a, it comes out as an a. Why? Because you're going to have the square root of a squared. A power of 2 cancels out a radical. So that's why you would have a. Just like the cube root of a cubed, the cube root cancels out a power of 3, that would equal a. Just like the fourth root of a to the fourth root cancels out with the power, that would equal a. All right? So now, let's look at B. Check this out, guys. How many, I have a fourth root here, right? How many 2's do I have? 2. How many do I need? I need 4 in total, right? So how many do I have to multiply to this? 2 more. How many x's do I have? How many do I need to pull 1 out? 1 more, you need 4. So, yeah, I'm going to multiply both top and bottom by the fourth root of 2 squared x. Fourth root of 2 squared x. Why is this crazy man doing this? Check it out. This is going to be 2 times the fourth root of 4x over the fourth root of, what's 2 squared times 2 squared, guys? Oh my God. 2 squared times 2 squared, guys. 2 to the fourth, leave it like that. And what's x to the third times x? X to the fourth. So now the denominator simplifies. So I've got 2 fourth root of 4x over 2x. Because I have 4 2's, which I need to pull 1 out, and I have 4 x's, which I need to pull 1 out. That is called rationalizing. We're going to do some more, so don't stress, and we still got time. But so far, does that make sense? You got to multiply that denominator by however many number of values or variables you need to be able to pull out one of that value from the radical. Yes, sir. Okay, in this case here, actually, yes. I can simplify those 2's, and I could go fourth root of 4x. Fourth root of 4x over x. Yes, sir. Because the 2's on the outside, they're coefficients. Okay. Now, let's see how this works here, guys. I've got the cube root of 5x squared over 12y squared z. First thing I'm going to do, break it up. Cube root of 5x squared over the cube root of 12y squared z. Okay. Yes, sir. Oh, okay. All right. When I'm doing this here, actually, let me, no, wrong one. Okay. Let me put this here. I've got to rationalize this denominator, okay? Some people will go ahead and multiply it by 12 squared. I would not do that. Oh, you know what? Why not? Yeah, let's make our lives easy. How many 12s do I have here? How many do I need to pull out? I need 2 more, right? Because I need 3 in total. So I'm going to multiply by the cube root of 12 squared y squared z over 3 12 squared, no, just y1 and z squared, y z squared. So now I'm going to have the cube root of 5 times 12 times 12. Always leave it easy for yourself. Don't multiply it out. Don't do 144 times 5. Do 5 times 12, which is 12 squared, times x squared y z squared over, what's 12 times 12 squared? 12 cubed, so that comes out as a 12. What's y squared times y? Y cubed, so it comes out as a y. What's z times z squared? Z cubed, so it comes out as a z. And now let's simplify this. Doesn't this break up into 4 times 3, right? Which is 2 times 2. And then this is 2 times 2 times 3. So I'm going to have 1, 2, 3 2s. So a 2 comes out. You with me, guys? A 2 comes out. And I have left over a 5, 2 3s, and a 2. So 5 times 6 times 9 is 45. Times 2, so that's 90. And then I got x squared, y, z squared, all of it over 12y z. Take a second to absorb that. That's as hard as it can get. Okay? Does that make sense? Yes, sir. Thank you, brother. Okay, you're asking about the question before. Come ask me about that later. What about this right now? Okay, what? Now you're putting your hands up. What? What? No. Now I'm answering you. What? Go. Question before. Go. What? Huh? What's x cubed times x, son? So don't I take out 1x? That was an awesome question. Thanks, man. All right, anyways, any real questions on this now? No. Okay. Last one. I got 1 minute left. So I want to get rid of this. I want to rationalize. So I'm going to multiply by the cube root of 5 squared y. Cube root of 5 squared y. So this is going to equal the cube root of 25 times 7, which is 140, 175? 175 xy over, what's 5 times 5 squared? 5 cubed, right? So that comes out as a 5. What's y squared times y? Y cubed, so it comes out as a y. Does that make sense, boys? Awesome. I think we're done. Yep, we're done. Thank you, guys. Good luck, and God bless you.